Hey A&Pers, this is Dr. Jones checking in. This is A&P1 Lecture Test 5, Video 25 on page 26. Usually this late in the test, we have lecture time, we have very little time left. I might be able to get 2 pages done in one video. Hopeful it doesn't make it take too long and then it won't record. So we'll see. It's a gorgeous day here as I record this. I do have the windows open. My father-in-law's outside banging on stuff. I don't know. He builds things. It's really quite interesting. He builds all kinds of stuff. So, but anyway. So why is the cerebral cortex folded? Top of page 26. Why all the little folds and lumps and bumps? Is otherwise it wouldn't fit in your skull. I have seen pictures. Occasionally they will find a brain that does not have folds in it, and it's usually someone who is of lower mental ability, because without all that cortex, you can't do as much of the thinky part. So the strategy is you need a lot of brain cells to make the strategies. Okay. The cerebral lobes are one linked to the opposite side of the body. So this left precentral gyrus moves to the right side of the body. This left postcentral gyrus receives the sensation from the right side of the body. Number 2, the hemispheres function differently. There are places like Broca's area and Wernicke's area that are only on one side or the other for speech and writing and things like that. They took the science and they kind of overblew it into this left-brained, right-brained thing. Everybody uses both sides. You might be better at things on the left side or better at things on the right side, but absolutely everybody uses both sides. And number 3, the areas overlap, which is great for us because when we have brain damage, often a nearby area can kind of take over that function, although it doesn't always work. The white matter of the cerebrum is made up of myelinated axons. Do I have a picture of that? Nope. Well, kind of. Here, you can see white matter. The white matter of the cerebrum, myelinated axons, myelin sheath in the CNS is formed by oligodendrocytes. You got it. And the corpus callosum here is the white matter that connects. I didn't turn the pen on. Pen color red. Corpus callosum is the white matter that connects the left hemisphere to the right hemisphere. And the internal capsule, which is this white matter right here, internal capsule, is white matter that is deep in the brain. It's in with the basal nuclei. So next, basal nuclei are gray matter deep in the brain. The caudate nucleus right here is our red Nike swoosh, caudate nucleus. And the putamen is the jelly bean. Where's that labeled? Putamen. Now, technically, you can clearly see here what our jelly bean is in lab is the lentiform nucleus. But we're not learning the globus pallidus in lab, so we're going to pretend in lab like the entire lentiform nucleus is the putamen, but really it's the two together. Didn't need to know that. Moving on. The basal nuclei, which is all of this gray matter in general, this is part of the caudate nucleus here, is involved with subconscious control of skeletal muscle tone and coordination of learned movement patterns. So you know that thing where you're learning to play football or to play piano or play guitar, and they call it muscle memory. Well, clearly muscle memory is not a thing, not in the muscles anyway. But the basal nuclei do help with that, the coordination of learned movement patterns. Parkinson's disease is a general gradualized increase in muscle tone. The reason why that's bad, an increase in muscle tone should be good, right? Except if all of your muscles, both antagonists, are extra tight, it's harder to move. So if your tricep is flexed really hard, it's hard to move your biceps. If your biceps is flexed, it's hard to move your triceps. That increase in tone makes it so much harder to move, and that's what causes the intention tremors in Parkinson's. With Parkinson's, you'll also see the fingers move across the thumb. They call it pill rolling. And walking is kind of a lean forward, almost kind of a falling forward more than a walking. And those are some things that are common with Parkinson's. The motor, sensory, and association areas of the cortex. The central sulcus separates the sensory and motor areas of the cortex. The precentral gyrus of the frontal lobe is anterior to the central sulcus and contains the primary motor cortex. We've already said that, so I'm going to keep going, and we're going to do both pages on this last video. There we go. There's the picture for it. The pyramidal cells are one of the lab slides. So make sure you look up the pictures of the lab slides in the lab resource course on Canvas that Dr. Chapa built for us. The pyramidal cells are neurons of the primary motor cortex. They control the skeletal muscles, so please look up what those look like. Next line, the post-central gyrus of the parietal lobe is posterior to the central sulcus, contains the primary sensory cortex. Okay, let's talk about lobes and cortices. We have a chart. We do have a chart. Okay, so first, the frontal lobe has the primary motor cortex, which does voluntary control of skeletal muscles, which I like to abbreviate SNS. Next, we have the primary sensory cortex. Let's write down that it's in the parietal lobe, and it is for sensation. Somatic sensation. Next, we're going to cross the chart. The occipital lobe has the visual cortex, which receives visual information. And then the temporal lobe I have on our chart twice because it has two different cortices that we need to know. One cortex, singular, plural of cortex is cortices. So a word that ends with X, they usually either turn it to a C or a G to make it plural, like one phalanx, two phalanges, one cortex, two cortices. Okay, and the auditory cortex does hearing, A-R-I-N-G, and the olfactory cortex does smell, because that's what olfaction is. And then all lobes have association areas which process. All right, next, below the box, the association areas interpret and coordinate. I keep looking at the camera. Integrative centers, disconnection syndrome is what you get after you cut the corpus callosum. Why on earth would you do that, you may ask? It's done sometimes with severe epilepsy cases, and it does decrease the frequency of severe epileptic seizures. But it does cause an interesting constellation of symptoms that I would like you to read about. Okay, we're not there yet. Sort of. Left and right have, we talked about the left and right have different jobs, and the corpus callosum connects them, so that's a nice visual of how that works. Oh, the cranial nerves. Okay, we're not doing the cranial nerves on this test. All right. The integrative centers, disconnection, we said that. Prefrontal cortex does the abstract intellectual functions, and by abstract, I mean things like predicting consequences, frustration, tension, anxiety, that kind of stuff. Now, what they used to do before they had all the psychotropic meds that they have now is a prefrontal lobotomy, where they put a rod, they would drill a hole next to the top of the eyebrow medially. Sorry, just under the eyebrow medially. And they would drill a hole and put a rod in and effectively scramble your prefrontal cortex. And that cuts down on all of these abstract intellectual functions like frustration and tension and anxiety. Unfortunately, it also cuts down on abstract functions like social niceties of wearing pants in public and using a toilet. And these things kind of go by the wayside. And it at a time when they had no other way to keep people from harming themselves or harming others, it was the best they could do. It was that or kill them. So a prefrontal lobotomy is better than a death sentence, I guess, but now we have psychotropic meds and other ways to help people, and that is not necessary. By today's standards, absolutely barbaric. Okay, and then the hemispheric lateralization is this picture. Each hemisphere does have different jobs: left, speech, language, and math; right, spatial analysis and analysis by touch. But both sides talk to each other, and they're both necessary. EEGs, electroencephalogram, is a printed report of the electrical activity of the brain. Aphasia affects the ability to speak or read, like a word salad is one kind of aphasia when people are saying just random words like left butterfly carrot, and they in their head they're saying turn right at the stoplight, but what's coming out is just random words. Word salad is a type of aphasia. All aphasias affect the ability to speak or read. Dyslexia does not affect the ability to speak. It only affects reading and writing. And it does not impact intelligence. In fact, it's usually seen with higher intelligence. There are a lot of people in the sciences with dyslexia and dysgraphia, which is difficulty writing, and they just factor in more time to read things, or if they can, they'll pay someone to help them by reading to them. And now there's lots of text-to-speech and speech-to-text, so there are lots of accommodations. Seizure is a temporary cerebral disorder with abnormal movements and sensations. And then epilepsies are a type of seizure disorder. All right, so that finishes page 27, and those were, this video covered the last 2 pages of chapter 14. And thank you again for your patience as I figure out a way to get my computer to record the stupid videos. So this has been ANP1 Test 5. And this was our last Test 5 video, which was video 24. I'm writing this down now. Over page 25 and 26. Is that what I did? Did I skip the video? I think no. Let's do 25 over pages 26 and 27. There we go. All right. Thank you as always for tuning in. Expect some T1 videos coming to a Canvas course near you soon. Dr. J out.